topic of this discussion will be colonization of space, space exploration, but I want to start from jokes about space. So I know, Michael, you have the great joke about the book and this movie Martian. So please start.
So when the book The Martian came out, we had at Johnson Space Center, there was a lot of fanfare. We had Andy Weir, the author, came to visit us. We had the premiere of the movie, and we had some of the actors out. And one of our head of public affairs was really pushing on everybody to come to these events. And as a joke, and how many of you have seen the movie The Martian? Or read the book, either one. So, great book, Andy Weir, fantastic guy. But what we did to give this leader at NASA a hard time is some of us, it was April 1st, which is a traditional day of pulling pranks. And we filled this gentleman's office desk and credenza with potatoes. Just, and we put up signs that said, come see the Mars analog in his office, and everybody got a big laugh out of it. So, but he ended up getting the last laugh. He took all the potatoes out of his office and made little signs on them to advertise events about Mars. We had a Mars week and things like that, and so he put them on all the tables in the cafeteria with signs on them. So it ended up being actually a really good marketing thing that he came up with, but it was fun. It's NASA. We have a good time.
That's incredible. So in my imagination, NASA is like very serious organization, and there are no places for jokes. But you broke my.
Yeah, no, we can have fun too, but we are very, very serious about a lot of subjects. Yes.
Thank you. So Robert, what about you? I think in like your long story, you have like some jokes about space exploration and.
You're taking me by surprise here. Jokes about space exploration. Drawing a blank. To me, the biggest joke in space exploration is NASA's Planetary Protection Program, which says we cannot bring microbes to other planets. But that is exactly what we intend to do. If we're sending people to other planets, we're sending microbes, we're sending all kinds of life. So you have half of NASA wanting to get to Mars and the other half wanting us to not get to Mars. And we'll see which half wins.
Okay, so very serious joke. Jakub?
I don't know if I have a joke. I have a small anecdote. Life of an astronomer. When I was younger, I'm young now. When I was younger than now, I was working on this telescope in Britain. And one night I was supposed to be observing an asteroid coming close to Earth. And we were all getting hyped up. It's gonna come close. It's not gonna hit. It's gonna pass by. And that's it. But unfortunately, the night before, we went out for a couple of drinks. I mean, as you say, we went for one beer. And you know how one beer ends. And there's a second beer, and I woke up in the morning. I thought in the morning, I wasn't sure. I woke up, basically, to a telephone. And there was a guy calling me from BBC. And I was like, what? Hello, who am I talking to? Well, I'm a journalist from BBC. I'm calling you. Have you heard about the meteorite? I was like, what meteorite? Well, apparently you were supposed to observe it. I was like, wait a second, what happened? Well, it hit Chelyabinsk. I was like, whoa, I'm so gonna get thrown out of my work for not observing the Chelyabinsk meteor. Then it turned out on that one day, fortunately, for me at least, there were two asteroids. One basically hit Chelyabinsk, almost hit Chelyabinsk, but still caused a lot of harm. The second one, fortunately, missed us. And I have to say, when he called me, my heart stopped. Because the asteroid that was flying past Earth, if this hit Chelyabinsk, there would be no Chelyabinsk. So when he called me, I was like absolutely terrified. But fortunately, the BBC gave me lessons beforehand how to deal with journalists. So apparently, if you don't know what to do, if a journalist approaches you and you don't know what to say, apparently the best thing to do is to say, I'm on my way to a meeting, I'll be back in 15 minutes. And then you quickly figure out what's going on, and then come back to them. So I did that and fortunately learned that about Chelyabinsk is a different asteroid. So all ended up well. The unfortunate thing was that by the end of the discussion, the BBC guy asked me, so are we safe? And I said, well, yeah, I think we're safe. So he said, oh, good, I'll tell the army, they asked. And he disconnected. And I was hoping we were safe.
That's, let me jump in, though. But you bring up a really interesting point, and that is, you know, there are programs where we're scanning the sky looking for potentially hazardous objects that could cross Earth orbit, those that could get close enough. And you know, like Chelyabinsk, I mean, often we miss, these things are hard to detect. They may have a very dark surface, you know, not be easily detectable. They could be coming out of the sun where you can't image them appropriately. So that's something that's, you know, all countries, I think, are engaged in trying to help find these sorts of potentially hazardous objects, because the idea is you really want to either give appropriate warning so that you know, you can clear an area, or if it's far enough out, maybe there's a way you could take some action. You know, a lot like certain disaster movies that occur, but you know, the idea is you want to find these things and figure out, do we have a problem?
And I think in this case, people were really afraid because asteroids have a tendency to come in pairs or triplets or even more. You know, could be an asteroid that just fractures into pieces, and then these pieces could be flying on the same trajectory. So if one hit Chelyabinsk, and I was supposed to be observing a bigger one, well, it might be on the same trajectory. It might be actually a danger to Earth. So when the guy said, I'm going to call the army, we're fine, he actually meant it. That, oh, I asked an astronomer, he says it's fine. So I have to say, I was truly afraid. But fortunately, as you know, what happens on a Russian street is on the internet everywhere the next 5 minutes. So fortunately, I was able to find a dashboard camera video of what happened in Chelyabinsk. And I could see, looking at where the sun is and where the driver was driving, that the Chelyabinsk meteor came, I think, from the south, and the one I was expecting was coming from the north. So it's completely opposite directions. No way it's part of the same asteroid.
Okay, so the beginning is promising.
So that's your story, and you're sticking with it.
Was that, sorry?
Sorry?
That's your story, and you're sticking with it, that they weren't part of the same asteroid.
Yes.
Well, it came from the opposite directions, so.
Okay. All right.
Okay. Yeah, let's move to another question. So, so how it's actually practical is like to colonize other planets? So let's start from you, probably.
How practical is it to colonize other planets? Well, I'm a specialist on exoplanets, so planets outside of the solar system. If you ask me how practical it is to colonize any of those, it's gonna be difficult for quite some time.
At least not this year.
So I think like the first thing we could do is like observe them better, map them better, figure out whether there is life there, etc., and then maybe if we manage to figure out some faster way of travel, we can start assessing whether we can get there or not. But at this point, at least when it comes to my areas of expertise, I don't think we can get to any of the exoplanets just yet. But these guys might know more about our planets.
Unless you think extinction is a good plan, it would seem to me that colonizing other planets is a quite practical idea. Not to try to run away from Earth and let Earth be hit, but in order to become a spacefaring species and be able to control the traffic of asteroids within our solar system and have that kind of reach. And then, yes, in order to create new branches of human civilization. I mean, you know, if you want to have posterity, you need to be a parent. All of my ancestors, without exception, were parents. And if you check your own ancestry, you might find a similar result. So if the human race on Earth wants to have progeny, we need to have it. We need to give birth to new branches of human civilization. And finally, in terms of the practical aspect, Well, sure. In terms of our own solar system, we're ready to begin now. I think we've been ready for a while. The politics have sometimes gone haywire and caused things that could have been done a while ago to have to wait. But it's in the cards right now. We're going to Mars, and we are going to settle it. And as far as going to the stars is concerned, we're not quite ready for that yet, but you can sketch it out already. Using fusion power, you could create rockets with exhaust velocities about 5% the speed of light. A properly designed rocket can achieve total velocities of about twice its exhaust velocity, 10% the speed of light, which means you could get to nearby stars in 4 or 5 decades. And at some point, people will be ready to attempt that. So this is the most practical thing we could do.
I've got to agree with both presenters. I mean, excellent points. I think, you know, the charts that you brought up this morning with the scale of the universe and all those sorts of things, I think kind of, and to bring up your point where you just made with some sort of, we can't get there on our current chemical propulsion system. We're going to need something different or better. And perhaps the first thing to do is, once we've discovered what are the right type of exoplanets that we want to explore, then it would be utilizing some sort of different propulsion system to get probes there, to get some more ground truth rather than just observing from here on Earth. Now, our sensing capabilities continue to get better and better and better, but you're probably at some point going to want to send some sort of probe. Now, there are no plans currently. We're just looking for the exoplanets, but I think that would that would head you in that direction. I agree with the points brought up by both our other speakers.
Actually, there are plans to send probes to other solar systems. There's an outfit called Breakthrough Starshot, which is attempting to develop a system in which
Yep, you're absolutely right. Thanks for reminding me of that one.
Yeah.
Appreciate it. Yep,
there is
right.
a ultra miniature spacecraft, perhaps with a mass of 10 grams, and with a solar sail, a foil that reflects light,
Yep.
and hit it with a very high-powered laser so that as it moves away, it continues to have light pressure on it. And they're hoping to get to 20% the speed of light, which would get that probe to Alpha Centauri in 20 years. Now they've got some technology to develop to do that, but they're working on it. And they got some serious people, and they have some serious money. I don't know if they're going to do that within 5 years, but my guess is we'll have interstellar probes of that kind launched within a few decades.
Yep. Eventually, I think we will head in that direction. And we'll have a lot more really tantalizing targets, I think, to go and look at.
I think the biggest problem there is that even the project you mentioned, I think the cost for R&D at this point is about 100 million to assess feasibility, not to build a mission. So 100 million is not a lot in space money. Space missions can cost upwards of billions. But as far as I understand, it costs about 100 million first to assess feasibility, finish the design, figure out what the actual speed is going to be, how are you going to first get there, secondly, how are you going to transmit data back to Earth, and then we're talking about something tiny. And the second question will be how to scale it up to a size where you can actually transport a human being, which is like a totally different ballgame.
Well, it certainly doesn't need 100 million to study a mission. You can study a mission for $100,000. But I've made a recommendation to Breakthrough Starshot that they back off a little bit and put the laser aside. That's the hardest part of the technology. Put out a prize for a miniature spacecraft, a 100-gram spacecraft. I bet you'd have students from MIT come up with one within 3 years, and make a solar sail that's thin and can be pushed by sunlight, and a system that can get you to Saturn in a year on a Saturn flyby probe as a first demonstration of this capability, and create a capability for quick probes to the outer solar system, faster by a factor of 10 than what we can do now. That's a first step. That would give real utility to their technology. And then take another step and go for missions to 550 astronomical units, which is about 1% of a light year. But that's a very interesting place to go because at that point there's a gravitational focus. The sun's gravity focuses light, and you could put a telescope there and make it very effective. And that's something that I think could be done within a few decades, and then take it from there, one step at a time.
Stepwise, I think, is, as you suggest, a stepwise program is the way to go.
Because like at the end, when we're talking about this like space exploration, and then we have the biggest budget. What we have is like government budgets, for example, US or like Chinese budget for the space exploration. But in the end, all of these countries, you can't just like start doing some like space exploration. You have your citizen, and you have to have their permit to do that. So. Do you think like the space exploration will be, the future of space exploration will be in the hand of the government, or it will be some like private company like Elon Musk or Jeff Bezos? So what do you see here? Like what will be?
Yeah. I can tell you who it's not going to be straight away. Because recently, I'm an advisor to the European Space Agency, and we actually organized something called the Citizens Debate across every ESA state. So there's 20-something states, people assembled in every country, and we had the same debate, the same points were raised in every single country at the same time, so we cannot influence one another. And we answered the same questions, and we made sure that we have a mix of specialists, non-specialists. It was quite interesting, and I actually have results in front of me, so I know what is the support across the European Space Agency states for space exploration, human space exploration, and space colonization. And what actually surprised us a little bit was that when you ask about the biggest achievements that the European Space Agency has had over the last 50 years, if you ask for the top 5 achievements, human spaceflight is not there. And if you ask if we should maintain human presence in space, 90% of the Europeans say yes. But if you ask, should we support space colonization, only 9% say they're in favor, and about 80% say they're against it. So I can tell you who is not going to support it. ESA told us that they will try to listen to this feedback, so we're pretty sure that the European Space Agency will not be supporting space colonization at least, but certainly will try to maintain human presence in space. However, the favorite targets for Europeans seems to be low Earth orbit plus maybe cislunar space, so next to the moon.
Well, the future belongs to those who dare. And if the European Space Agency doesn't want to send humans to other worlds, other people will. And we've had, well, first of all, I think the American Space Agency has a bit more initiative and might well send people to the moon in particular within a decade. But we also have a breakthrough has occurred in private space. I mean, what Elon Musk has done is profound. He has shown that it is possible for an entrepreneurial venture to do things that previously it was only thought that governments of superpowers could do, or combinations of governments amounting to, in totality to a superpower, such as the European agency. And not only do it, but do it in half the time at 1/10 the cost or less, and do things that they had never even attempted, such as build reusable launch vehicles that fly back to the launch pad. And as a result of this, not only is Musk proceeding with a plan to get humans to Mars, but he has made it quite clear that this is possible, and he is going to have emulators and competitors from all over the world. There are going to be would-be SpaceXs from other American companies competing against him, and I believe from European companies despite ESA. And I think there'll be, I'm sure there'll be a Chinese SpaceX, and I think that someday, and maybe not that far off, there'll be a Ukrainian SpaceX. And we're going to have a private space race that will open up the new frontier. okay, because not everyone needs to agree to go to Mars. Only the people who actually go to Mars need to agree to go to Mars. So, and I think this is how initiative has been in a lot of places, you know? I mean, the whole world didn't agree with Christopher Columbus, but he went. And he had some backing, that's for sure, but not everybody was willing to back him. He looked a long time for a single backer. So I think there's, I actually agree that the reach for Mars won't be achieved by a universal consensus that all the nations in the United Nations will vote together to do it. But those willing to do it will do it. And in particular, I actually think that this is going to work out as a public-private partnership. NASA, of course, is going to continue to launch unmanned probes to Mars and other planets that are creating a great deal of information. They have now discovered glaciers on Mars as far south as 40 degrees north. That's the same latitude as Athens on Earth. Glaciers with a total size 3 million cubic kilometers. That's equal to all the fresh water in North America have been found on Mars. That's a huge resource for exploration. And there are going to be people going to take advantage of that. And, you know, here's Musk. He's developing a significant fraction of the flight hardware set needed to send humans to Mars. And as he does that, and Bezos does that, and these other SpaceXs that pop up do parts of that, pretty soon it's going to be apparent to the political class in the United States that, hey, humans to Mars is not that far off. If we started a program now, we could be there in 6 years because we have the booster, we have the capsule, we have the habitat, we've got all these different pieces. All we got to do is put them together and do it. And at that point, it becomes attractive and they'll do it. And if they don't rise to that, eventually it becomes so attractive that people with private money will just do it without it. But at this point, I still think that the American political class has enough on the ball that if it's made easy enough for them, they'll decide to do it. And it will be a partnership between NASA and the entrepreneurs that will get us to the moon, to Mars, and beyond.
Can't really disagree with what Robert's talking about. I mean, so the next stepwise thing that NASA's talking about is cislunar space and lunar, and doing that with international partners and with commercial space companies. And if a company leapfrogs and decides to go to Mars sooner, you know, certainly NASA will have discussions with them about how we can partner. It will become whatever is the most expeditious way to get our exploration goals done, and if that ends up being with a commercial company that's willing to do more things, we're more than willing to partner with folks like that. Colonization, to get back to the original question, I mean, really the goal right now is exploration. We want to explore. We do want to get people off of the Earth, cislunar space, lunar surface, Mars being the current ultimate goal. But you know what's interesting is when you look at everything, I mean, there's other destinations in our solar system that we would eventually like to send people to go look at someday, but our current policy is Mars is the ultimate goal, and we'll do it, you know, we'll do it with the appropriate partners that evolve as the situation does, as these gentlemen have just noted.
If I could clarify, one other response we got for the ESA debate is whether ESA should collaborate with private companies, and especially like new space, smaller or like sort of rapidly developing companies. 84% people here said yes, definitely. We would like ESA to change from basically financing or buying hardware from the same suppliers all the time into buying from new, slightly more risky but potentially interesting suppliers. So that's happening. However, I have to say that I think I agree with you with the fact that, for example, what happened with Elon Musk in developing, you know, his rockets and his hardware, the first big contracts he got were from NASA. And then he's been developing them for, you know, primarily commercial purposes. So then taking a step further and flying to Mars, this is a non-commercial venture, at least to start with. So I agree. I would totally love to see, for example, a European company, you know, building up expertise in building cheap, maybe reusable hardware, and then deciding on their own dime potentially, unless there was somebody happy to support them, to maybe take the next step and then fly, you know, to another planet.
Well, I see here like one very important thing. For example, what Elon Musk do very well is like popularization of the space. And for example, when he bring his car to the space, like people all over the world like watch this. That's actually like art, you know. It's more in art than science, I could say. But previously, I see something like this only when like Steve Jobs present iPhones. So all over the world, people look like how this new iPhones looks like. So, but from other side, I know such things like, for example, NASA. You opened patents for like agriculture, like whatever you do in the space for the agriculture. So like NASA opened these patents and like everyone can use it. For example, I know that a lot of my friends was waiting for this, like they was very enthusiastic. So I'm wondering what we can do else or more just to popularize the space more, because it's so incredible things we use every day that's happened because we explore some space or like same solar panels, for example, like so innovative solar panels right now in the space, and now we use it on the Earth as well. So what's your idea, like how we can popularize space?
Well, by doing it. Look, you know, when the Pathfinder probe landed on Mars in 1997, it literally blew out the internet in terms of the hits on the NASA website. And again, when Curiosity landed in 2012, even though that was a much bigger internet by then, it was blown to pieces, you know. And, you know, Hubble. You can go into any college dormitory, you will find photographs made by the Hubble Space Telescope on the dorm walls. This is the great art of our time. I think, and when Musk did the Falcon Heavy demonstration in February of this year, he had the whole world watching. I mean, all you need to do to mobilize support for a bold space program is to have one. And they will come because people are waiting for this. Look, there is a general understanding among a lot of people, certainly in the United States, that a positive human future means human expansion into space. They want to see that, okay? I mean, that's why, well, The Martian was so popular as we can do it. That's what that movie said. We can do it. And people said, yeah, we can do it. We want to do it. So I think the best thing that NASA could do to mobilize public support for the space program is just step up its game and get back. I mean, when I was a kid, we were going to the moon, and believe me, people were paying attention. And as far as the practical benefits are concerned, yeah, sure, NASA and the companies funded by NASA certainly have made a variety of technological innovations of considerable utility, and NASA publishes a magazine several times a year describing recent such developments called Spin-Off. But I think the real spin-off has been the intellectual capital generated. You know, the number of science graduates in the United States during the Apollo period doubled, and in some fields tripled, at every level from high school to college to PhD, because people wanted to be part of this thing. And we've been benefiting from that intellectual capital ever since. I mean, NASA sometimes makes claims, though, we're going to find the cure to cancer on the space station. I actually find that improbable. But one thing I'm willing to bet anybody $1,000, that when they finally do find the cure to cancer, that there'll be a significant number of people on the team who were inspired to become biologists by the space program, okay? A significant number, maybe even the majority. And certainly in Silicon Valley, the people who made the computer revolution, and in numerous other fields. This is benefiting us massively every day. The thing that drives progress, the things that raise living standards is intellectual capital. And there has been no stronger generator of intellectual capital than the space program.
Let me just add on to what Dr. Zubrin's saying.
Yeah.
You know, it's really interesting. Probably when you got your engineering degrees, you know, a lot of what NASA was doing, they were doing it at that time. It had never been done before. It was the first time. So probably pieces of that, you know, you might have the rocket equation, but it wasn't like you had, well, here's a schematic of this engine and how they work and how to, you know, comparative specific impulse of different engines and fuel combinations and things like that. When I was in college 30 plus years ago, those things were already in the books. You had comparisons. And it was interesting because at the time, my friends and I talked about, you know, any of us could probably go build an engine, even 30 years ago. I mean, all of the information was being taught out there. It wasn't like NASA had it all. It was out in every university that had an aerospace engineering department. And you know, so you could learn the practical parts of building rocket engines. And we talked about that 30 years ago. It would be like, wow, you know, right now if you want to go do this, there were just a handful of companies that did that, government organizations or companies that were involved in that. And we speculated 30 years ago how it's going to be neat. Someday, there could be other companies and other places that you could go to work and build rocket engines and do space exploration. And it's been neat to see that evolution happen through time. And I think it's extremely exciting. And it's exciting to us at NASA because we've seen where we've been able to just put out sort of a proposal. Hey, we would like companies to consider sending cargo to the space station, and look where we are now. We have had companies that have been doing that for a number of years. And so another proposal, we would like companies to consider sending astronauts to the space station, and we're on the precipice of that happening. And it's a completely different model than the way we've ever operated before from a commercial standpoint. And I think we're going to take that model, evolve it based upon what we're learning from the companies and how they're able to operate and whether they're more nimble than we even gave them credit for. And we'll kind of change how our policies and partnerships go in the future, because we NASA, you know, our goal is to explore. The vehicle to get us there, we could take any sort of ride. You know, as long as our goals are met and met safely and those sorts of things.
I think I would second that, especially the fact that what you said about is sort of the uniqueness. So like with every space mission, I remember Pathfinder. I remember I was annoyed by the fact that I asked my dad, I was a little boy, I asked my dad, wake me up, I want to see the landing. I have no idea what it is that is landing on this other planet, but I really want to see it. And he didn't wake me up. So I decided to study astronomy and become an astronomer and never again miss astro stuff, because I'll be doing it myself. So I totally understand and I agree with that. But the thing is, coming back to your original question, I think what you are saying also is that with time, maybe we sometimes become a little bit less sensitive to new announcements regarding space. For example, you know, first Hubble Space Telescope images, absolutely fantastic. Pillars of creation, amazing. Take a picture of Hubble Space Telescope of another nebula now, shown to your friend, he's like, well, there's lots of those on the internet. When it comes to new landings, for example, Curiosity was amazing. You had the sky crane maneuver, the 7 minutes of terror, something new. Voyagers are still exciting. They have just left the solar system. It's new and unique. But I think what Musk is doing that's really cool is he brings the unique back. What he does is like, I'm going to launch a rocket and it's going to land. This has never been done before. We've done that a couple of times. People stopped watching launches of Falcon 9. Well, how about a double launch this time? We've never done this one before. And then how about we launch my car into space? That's unique. So basically, I kind of feel like this is bringing the uniqueness of space flight back, something that catches your interest. But going back to Apollo, I remember, not myself, but reading about the fact that the public interest, apparently, from launch to launch, was waning. When it comes to the viewing numbers on the TV, the numbers were going slowly down. People were getting used to even to landing on the moon. And I have to say, from a European perspective, I think we always had this approach, which was very pragmatic, to always come second. Sort of like, instead of developing the newest, best Ariane rocket, we're just going to build a working Ariane rocket that we are pretty sure that's going to be an effective way to spend taxpayers' money. So we don't do very many very new and unique things, unfortunately.
Thank you, gentlemen, for this really interesting conversation. I propose move to the questions from the auditory. I believe we have some. Okay, I see like 3 hands. So unfortunately, we have time only like for 3 questions. So you have to translate if it's not.
Hello, I have a question for both 3 of you. It's more of, I know you're engineers and scientists, but it's more about like long-term social outcomes of colonization of space. You know, like imagine a future colony on Moon or on Mars, as we're talking. You know, right now we have people going on like International Space Station for a year and coming back. It's like a work. If you don't want to do it anymore, you don't do it anymore. You can retire then and leave on Earth. But for now, any Mars mission, any Mars colonization mission is one-way ticket. So people go there and they should be a scientist, they should be researchers, going to do it till the end, like till the end of the life. They're not going to be able really to retire, or so it's like if they don't want to do it, they still must do it because it's what they choose. And also another question is, if we establish a colony, we don't plan we plan to like make it bigger, and probably they're going to be people who are going to, you know, make children because they're going to live there for like the entire life. How we cannot force those children to become a scientist, but we will need to spend a lot of money to, you know, keep like those new people on Mars. And if the person want to retire, you know, if you live until 90-year-old, 100-year-old on Mars, you don't, you know, you don't want to work anymore. You still need to retire, and there's still going to be a lot of money spent on keeping you alive on Mars. And those children, how practical this is, or are we going to just prohibit for those people to make children? What's going to be like the social?
Okay, can I answer this? All right, look, as far as the human future in space is concerned, you know, there'll be many Mars colonies, and they'll be organized by different people with different ideas of what's the right way to do it. And the ones that do have better ideas on how to organize human society than what we have here will be the ones that succeed, and the ones that have worse ideas will fail. But it's these sorts of noble experiments that provide an opportunity for us to find a better way forward. But I want to address a very important point here that really needs to be said, and in particular here in Ukraine. Okay. What is the greatest threat to the human future? I don't think it's global warming or resource exhaustion or even asteroid impacts. I think the greatest threat to the human future is precisely the thing that caused the greatest disasters to humanity in the past, which is to say, bad ideas. And in particular, okay, there's one bad idea which is behind all the worst human-caused disasters of the 20th century, all of which were witnessed here in Ukraine, including World War I, World War II, the Holocaust, the Holodomor, all of it. And that idea is that there's only so much to go around, and so all nations are fundamentally enemies, and we got to get rid of those other people over there so there'll be something for us. Okay, this is the idea manifesting in a number of different forms, but it is the idea that caused all these disasters and which threatens to cause even worse in the 21st century. I mean, I can tell you for a fact, because I have spoken to them, that there are people in the Pentagon today who look at the rise of China and say it has to be stopped because if they become developed, they'll all have cars, they'll use up oil, there'll be nothing for us, it has to be stopped. And you can bet that there are people in Beijing and Moscow on the other side of the chessboard looking at the United States the same way. And if that idea is allowed to prevail, we will have human-caused disasters, we will have global wars and all the rest of it in the 21st century that make the things that happened in the 20th look like little skirmishes. But that idea has to be refuted. And the way to refute it is to show that it is not true that there's only so much to go around. It is not true that the nations of the earth are fundamentally competitors like rats in a cage fighting for one little piece of cheese that's there. That the bars of that cage are illusions. And that fundamentally, even if we can't see it, that de facto we are partners in a great enterprise of expanding the human prospect, of taking worlds that are out there and making them places that people can live. And the two people in a cage should not be fighting over the cheese. They should be working to break open the cage. And the enterprise into space, which is something to which all nations can contribute, and certainly all the nations that really have the capability of causing a lot of trouble should contribute, okay, is a joint enterprise that not only brings humanity together, but demonstrates that humanity are fundamentally allies. And it is by doing this, by refuting this false idea that resources are finite and that we must fight over. People say, why are you spending so much time thinking about Earth, about space? You should be thinking about Earth. Well, I think if people spent more time thinking about how to open up new worlds in space rather than how to fight over this one, we'd be a lot better off. And so that's what we got to do. And I think that's why I think the space venture is the most important thing about the human future. It is not a question that we're going to bring uranium from Mars back to Earth so we'll have fuel for the nuclear reactors. It's a question that by going to Mars, we will show that it is the human beings are the fundamental resource, and that there's no such thing as a natural resource. There's only natural raw materials, and it is human beings that are resourceful, and that working together we can create infinite resources.
My name is Alana Bech. I am a student of Taras Shevchenko National University, and I have a question for you. So, in recent film by Chris Payne, Do You Trust Your Computer? Elon Musk says that we should colonize Mars to have an alternative for humanity in case the human existence on the Earth will be under danger. And he says that artificial intelligence and its rapid development is one of that reasons which can threat humanity, and which rapid development is really dangerous us. So do you think that artificial intelligence really can be dangerous for humanity, although it is very important for science? Thank you very much.
Well, I think the greatest danger to humanity is artificial stupidity.
I think, when it comes to talking to them, so one thing regarding Elon Musk, and he also owns a company that develops AI, so very contradictory man. But at least he knows the devil that he might be willing to fight, or he knows what he's running away from. But the thing about AI is, as I'm sure many of people here in the audience would know, there's AI and there is AI. So I think what we are kind of thinking, could be scary is having the proper general AI, the one that overtakes us in our intelligence and then potentially takes over the world, over internet, whatever. But typically nowadays when we work on AI, we work for a very sort of specialist AI, which has a restricted number of skills related to a specific area. So I don't think anybody is afraid of that one. So when it comes to the fear of the general AI, the universal AI, the one that would actually be cleverer than us and potentially be able to harm us by accident, potentially, it seems to be, unless somebody in the audience in here has some secret knowledge when it comes to development of such AI, me personally, I don't, spend sleepless nights worrying about that. It seems to be more of a philosophical question. I think the bigger problem I see right now, and that's a serious one, is that even not so clever, even the stupid AI, is changing the fabric of the countries we live in. In Poland currently, we are catching up a little bit, And I've seen a recent study saying that about 40% of the jobs that are basically considered to be safe up until recently could be replaced by some sort of an algorithm. And that is a challenge. I mean, if people will have to work less to supply ourselves with enough stuff to survive, then what else will we be doing? Are we going to move to other jobs that basically are what sometimes considered useless? I would say, many years ago, you would say, well, you try to survive on this planet. Having a job of a journalist would be useless. But a number of years later, well, I don't fear for lack of food tomorrow or next week. I actually fear for lack of good journalism. And I think journalists, very useful. But maybe a couple of years later, journalists might be potentially automatized. And then we will figure out there's another job that is very useful. And we would like to have that job there.